Hello everyone, I'm Ashley, the engineer at Andover Norton, as Carl's introduced me. Some of you may wonder how I got into Norton motorcycles. Well, it all started back in 1995 when I bought a Mark III Commando to get to and from the dockyard in Portsmouth. It was the only bike at the time that was cheap to run, cheap to insure and get up and down the M27. My engineering experience comes from the Royal Navy. I spent 4 years doing an electromechanical engineering apprenticeship, specialising in weapon engineering back in the mid-80s. I am trained to maintain and look after, instruct and teach on everything from a 9mm pistol through to weapon discharge systems, including submarine discharge systems. During that time, I spent 14 years on submarines, dealing with watertight and nuclear integrity. Failure is not an option. I do get people ring me up and say, I'm an aircraft engineer. Well, I'm a weapon engineer. Let's put it this way. When was the last time you heard of a weapon killing its operator? When was the last time you heard of an aircraft falling out of the sky? Sorry, Boeing. It seems to be weekly. Right. So the Mark III I had, as some of you may remember, we had the 1998, the centenary in Bracebridge Street. Well, I was riding up to that on a Sunday morning and my bike wouldn't keep up with the other Nortons, even though we were travelling at speeds far exceeding 70 mile an hour back then. The cam was shot. Being a Mark III, it was effectively it's just Cadbury's cam, really, made of chocolate. Now, this brings us on to the fact that cams and followers have always been a problem with the actual Norton twin engine. Back in the 60s, not so, but it got progressively worse through the 70s. There must be reason for this, and for that, I'm going to explain what I found. Now, back at Andover Norton, we've got the purchasing records going back to the 70s and beyond, and we've also got written notes from the 70s all the way up to modern day. Those files may have useful information. We also could understand what was different in the 60s to what was different in the 70s and up to modern day times. And we also knew what worked in commerce. Now, I'll carry on with this. Followers were always being, the followers are too hard, they're too soft, whatever. Nonsense. My predecessor, Pete Morris, that some of you may know, always had a problem where some of the followers that were used in the tappets were glass hard and the grinders would refuse to grind them. So we could discount tappets being too hard, too soft, etc. But what was the problem? Why were we seeing tappets and cam lobes failing? That's a little bit about me. Right, through history, we've had the two-piece, the dummy racer version, the one-piece version follower that we got now. The early cams were made of steel, and they were just case-hardened, and they seemed to work pretty well. We then moved through into the 70s, where the Mark III started to use a nitrided cam. Herein lies some of that problem. Those early days of nitriding are not what they are today. The Mark III chocolate cam is like I've explained, and the latest version, which is EM40, which is plasma nitrided with the white layer polished. It's most probably about the best cam out there. Now, some of you will say, what about chill cast iron? We looked at chill cast iron. Our patterns were getting to the point where they weren't effectively working. So we looked at getting them remade. Now, we went to China because that was the only place that was prepared to entertain making the chilled cast cam patterns and cast them. They came in, just for the pattern, £18,000. This is back 6 years ago. And they also wanted 30,000 blanks on that first order as well. So that was just prohibitive. The amount of cams being swapped out in the world, we'd be still selling them in over 100 years' time. It wasn't viable. Right, the issues of the past. The old cam, the old follower, it's a two-piece design that you're all aware of. It has a cast iron body and a Delchrome C foot. Those two are furnace brazed together. And of course, the amount of processes we were getting a loss rate of between 18 and 20%, which is way too much. So the solution seemed to be this day and age is to make it in one piece, which is all well and good, but who was going to make it? No one in the UK was interested. So in the end, we had to go to a company that was originally based in the UK, but now in Germany. Their parent company is American parent, Kenner Metals, big, global renowned, hard-facing company. That's the tappets there. So now you can see now our two-piece design was loss heavy and expensive to do. The modern one was less process, less loss, hardness. Now with the material we use now, it's cobalt chrome, and we can control the hardness on that by varying the composition of the material to get into the window where we needed to be to suit cams that are still about from the 60s and 70s to the modern EN cams, and for those in America who like welding stellite onto a cam. We needed to have a follower that could accommodate all of those. The material that we use is not hard. Now that's going to surprise some people. It's not a hard material at all. It's actually sits between about 52 and 54 Rockwell on the scale, which some people might find surprising, but it has a very good wear characteristic. When we went to this company in Germany, we said, look, this tappet, this follower, needs to work on cams that are stellite welded. And they're like, well, stellite's not that hard. When you weld stellite onto a cam, you don't get much hardness out of that, but what you do get is good wear characteristic. That's when the penny starts to drop, that something somewhere was not right. Back in 2001, Norman White had a cam failure and a tappet failure. He said that the lobe and the tappet were of similar hardness. Who remembers Bob Reynolds? Some of you may remember Bob. Bob Reynolds, who was a predecessor way back prior to 2009, he sent the cam away to be tested. They tested the back of the lobe and found it was very similar in hardness to the tappet. What he didn't understand was they just said it's all too soft. What they didn't do was test the other lobes on the cam. Now this got me thinking, when you get a cam come back from a customer, it's got a damaged lobe or a damaged follower, it's damaged. What point is there in testing it? It's not going to tell you anything. So on some of the cams I had back, and I also tested new cams, I tested some of the lobes. Some of the lobes in cams that have done many thousands of miles, you might get one lobe that's gone and you might get another one that's not. We found the good lobes were sometimes softer than the one that's failed. So now things are starting to fall into place. The problem with that is what's actually going on. And we found that it was a case of similar hardness that was causing the cams to fail. But you need to be able to avoid it. Bearing in mind, we're working in a hardness window now, which then becomes a little bit problematic. The casting of the tappets wasn't successful at first. We had these investment casts, and we could see that we were getting gassing issues in there. But once we changed the composition of the alloy, the cobalt chrome alloy, we managed to get it so we could get good samples. Hard as anything to grind, but the one-piece tappet is a good bit of kit. We've only had 2 sets back from the same engine. That same engine, somebody put them in. He went up the A303, it seized. He refitted those tappets back into the engine, went up the A303, it seized. He said it must be the tappet's fault. 3 months later, he comes in and says, oh, no, it wasn't the tappet's fault, it was a lubrication, it was being starved of oil. Those tappets were still good enough to put back into an engine. That cobalt chrome stuff is tough stuff. You'll see why in a minute. Now, with the cams, now, at Andover Norton, we test purchase items from all over the world, from various places. And I will admit, we test purchase from our competitors. And some of our suppliers, we'll get stuff tested at UCAS-approved laboratories to find out what's going on. They do the same to us. We do the same to them. It's not unusual. It's common in business practice. So we had a cam from a supplier in the UK, and it wasn't Norville, by the way. It was a EN cam. I sent that for section, composition, and the actual nitride case measurement on it. Let's put it this way. It came back. One, it wasn't the material they claimed it was. Two, the nitride case had been shown the furnace door, right? But it worked. Now you've got to start thinking, hang on, why is this cam working? Why do these cams work? We know that the steel cams work. So what we think is happening with the EN cams is the nitride layer, when it goes on, is very, very hard, but it wears. But it will wear rapidly to a point that it will run on the underlying hardness of the metal of the cam. But it still gives enough hardness separation to carry on running perfectly. So it fails, but fails in a safe manner and still carries on running. Most of you still running now and most probably not even notice. And that's what we think is happening with the EN cams. We had the tappets made eventually, back to the followers. We had the followers made and we needed to test them. So we sent them out to America. Somebody had a test rig out there. There was a few things not right with the tappets, but he managed to put those right. It was just the precision of the grinding. So he'd done that and put them in his test rig. And this is a lucky failure. He put them in his test rig, tested one cam, and he found a few problems, corrected them, put them back in, thought, right, happy with this. He set the test rig up to run constantly at the equivalent rate of 7,000 RPM. He then went to bed with the test rig running. At about 4 in the morning, he woke up and there's a mighty clattering coming out the garage. One of the oil injection nozzles he uses to cool on this rig had failed, to the extent that the cam and the tappets was solid and stopped the engine. That there on the right-hand side, you can see that nice shiny flat area. That is molten camshaft on the face of a one-piece tappet. Yeah, so that's how hot it got, to the extent the cam had melted. When that went under the microscope, and then we spoke to the people that made the tappets, they turned around and said, if you'd have just ground that off and put them back in the engine, you could have reused them, because the underlying material wasn't even affected by the heat, as you'd expect with cobalt and chrome. Now, one of the things that came out of that was the fact that these tappets are expensive, but they're very, very good. They run at about 52 to 54 Rockwell, and we tailor that with the composition. We've also moved over to EM40 cams, and likewise, since we've been selling those, we've only had one back, and that was because it had a mechanical nick in it by a tool. The rest of them are out there, all running, all perfect. Never had one back. So at the moment, I'd like to think that the current setup we got and the parts that are being supplied, cam and follower issues are now null and void. They're redundant now. We just don't see those problems occurring again with the Norton twin engine. And one of the things say, well, it's not hard enough, it's not hard enough. Now, if you increase hardness, you get a problem in a camshaft where if you lose control of the tappet will come down and hammer onto the actual cam if you lose control of your valve train. Now, that in itself is not necessarily a problem, and some people use it to their advantage because you can, in some cases, get more power if you loft your followers. Now, the impact when it comes back down does two things. It can work hard on the material, and it can cause the surface to surface fracture, and then it can granulate. Once that granulation occurs and it comes away, your cam and your follower, they're not going to last. They're just going to be gone within another few minutes. So the material is also capable of being able to withstand impact without impact hardening, or if it surface fractures, again, not ideal, but not a problem in itself, it doesn't granulate away. And that's something we're looking at with these cams. So it's okay to have impact, and if you lose control of your valve train and it impacts, it's not going to do any harm. The EM40 cams and the followers will take it. Now, I know that's surprising to some of you that what we're actually running now is a lot softer. And of course, one of the problems was a race to ever increase in hardness. If you go hard, you tend to go more brittle. And then that's something we've tried to avoid. Now we've gone back the other way. And of course, these ideas are not something I found out. I'm just the one that managed to put the various pieces of this puzzle together from the various people out there that got close in the past. And at the moment, all's good. We just don't get tappets back, we just don't get cams back. And I think there's other people that sell EM40 cams that will also claim that as well. You just don't get a problem with them. All right, any questions at all, or questions? Or was that quite surprising for a lot of people? Yeah.
Just one. Have you got any recommendations on oil? What engine oil do you use nowadays? I know what I'm using. I don't know what.
Do you know what you're using? Right. I'll tell what I use, and this goes back to before I joined Andover Norton. When money was tight and the kids were little, I couldn't afford the top range oils, all the rest of it. So I bought Tesco's own brand 5W40, fully synthetic, and threw that in the Norton. And I run that for over 14 years. All right. Now, one of the things that we did do during COVID, you know when all those heat temperature guns were around, was that we used them to test the bikes. So when people pull up in the car park, we go out there and measure the temperature near the plug and the temperature on the tappet tunnel. What we found is the temperature at the tappet tunnel is as hot as it gets near the plug. Yeah, because there's a lot of friction going on down there. I would rather go for something like a 10W40, 20W40, 20W50 type oil to get oil down onto that cam as quick as possible to start when you start the bike up. And two, I always run my Nortons so the engine runs with higher revs. Some people want the bike to cruise at 60, 70 with quite low revs. I'm quite happy to have quite high revs because I want that oil running past that cam, lubricating and doing the other thing oil does, removing the heat from that area. But any oil you do buy should contain ZDDP. Manufacturers will tell you if it contains that, because if you put it in some vehicles, it can cause damage. Any other questions?
There's a tremendous difference between a Dominator, for example, which gets a very poor flow of oil back from the head down the tunnel.
Yep.
Whereas a Commando is usually considerably more.
Yeah.
You don't find that the Dominator ones run dry and fail more often for any reason. They don't seem to.
No, we use at our place in our dummy, we just use multi-grade in the dummy. At our place, we stick it in customers' bikes, and we've never heard anything untoward about it. So I think it's the case really with, especially with a dummy where you're getting intermittent oil into the head. You want a decent oil going up there to do that job. This gentleman here had a question.
Is the takeaway from what you were saying about hardness that you have to have the similar hardness is bad?
Similar hardness is really bad, yeah. Don't want to do that. Right. But you need to be able to get away from that. And of course, that's why we think that some of the EN cams that are out there with hardly any nitrided case on, we know they work in engines. And we think the reason being is that nitride case doesn't last. It just gets worn away. In which case the cam is then running on its core toughness of material, but it's still got an adequate sort of 3 or 4 point separation in hardness from the tappets that are running on it. So it'll carry on running fine. And that sort of bears out what we found when we tested some of the older cams and cams that have been used, because some of the lobes that had not been worn were actually quite soft. And we think that they were untouched because the tappet was quite hard.
The takeaway lesson of that would seem to be that if you've got an engine where your cam was shaped or the tappets have gone, then you really need to replace the whole caboodle because you don't know if you're, unless you...
Yeah, you can do, but the various combinations, because one of the things we found is, even the softest tappets we found was still had enough separation above the hardness of EM40, even if you was to run it on plain EM40 without a nitride on it. So if you see what I'm saying, is that the EM material is still going to be safe, even if it's just running on as if it's never been nitrided in the first place. It's still going to run. You on?
I bought a new set of cam followers.
Yeah.
And I didn't use them. You know the reason why?
Why?
I couldn't fit them in. They were too tight. I had an old cylinder, which was,
Yeah.
had a good bore.
Yeah.
And I bought them from a supplier from Andover Norton.
Yeah, so you get in touch again.
But they were much too tight. And I know with Emery Crawford, but I didn't. What's the solution? They are in my shed.
That's fine. Send them back. We'll certainly take them back and give you a full refund on them. But I will do, for those that don't know how to adjust tappets to make sure they go in a bore. Because bear in mind, the ones we get a German precision made, you know, they're made to a pretty tight tolerance on the grinding. There is a way you can do it. And I know this gentleman said emery cloth. With these new cobalt chrome ones, if you've got a bit of emery cloth, I just hope you've got enough years left of your life to try and get them to fit, because it's really hard to get them. Yeah. No, we can adjust the tappet. I've got some over on the stand, and I can show you. Come over to the stand afterwards. I'll show you how you can do it. If you've got access to a linisher, you can do it. Andover Norton. We're at Andover Norton, where I think you came over and saw the Combat 650 single. Yeah, come back over there and I'll show you how to do it. Yeah, it's dead easy. Everyone, what some people do, if they don't go in, or they find there's variation in the tappets and the tightness, they put it on a bit of wet and dry on a surface plate, and they would figure of 8 the flat side. It's not really the best way to do it, because what you do is closing your gap up on your anti-rotation plate. You can actually, if you've got a linisher, use it, and you can actually do the radius of it. If need be, I'll do a video and we'll get that, show people how to do it, because it's dead easy to do. And you'd struggle to take the material off. It's tough stuff. Yeah, anyone that knows with stellite, because cobalt chrome's effectively a stellite material. Yeah, if you're using wet and dry on it, you're going to be there a long time. But yeah, we can sort that out for you. That's not a problem. We can resolve that. Anyone else? Interesting? Brilliant. Yeah, a little bit different.